Hi, this is Assistant Professor Karen Browse with UMass Amherst, and I'm going to be introducing setting up Rhino models for using Rhinocam and our CNC router. The first thing I'm going to talk about is really how to set up your files, and while in particular I'm going to talk about the sequence that we're doing in Analysis and Representation 2, really this sequence will also work for anybody trying to learn how to use Rhinocam and our router. In particular for this project, we're going to be starting with using foam, and it's much easier as a practice project for us to work with materials that are only 2 foot wide rather than 4 foot wide, although our router can handle 4 foot wide materials. So I'm just starting by setting up a template here, and the template assumes that you have a 2 foot wide piece of material, which is how we've purchased the foam. It does have a tongue and groove edge, so we're going to move your model in 2 inches, and in this case for this model we're just going to work with the 16-inch square that we're going to offset 4 inches from all the edges just to give us enough clearance in case we keep working with these files and we want to start flipping over the materials and milling the backside. For this first assignment we're just going to work with the top side, but I would like everybody to set up a template that looks like this. Once you have that set up, you can set up a piece of stock around it, the foam that's going to go around your surface that you're going to be working with, so you can just extrude that. And then you're going to start generating surface. So we've already done this as part of our first week's exercise. We've generated some surfaces, so everybody has a surface that they're working with. In particular, I'm just going to start showing this one, which is a height field. It's not one of the ones I milled for this class, but I want to show you because I want to show you a little bit about steep surfaces first. So before you even are getting to use Rhinocam, a couple things I would recommend. The first is you can see if I zoom out that I've really cleaned out the rest of my file. So in class we really emphasize an iterative process and developing a lot of different things that you're working with. But when you're coming down to milling your piece, it's really much better to just clean out your file, get rid of any extraneous materials, and just work starting at the 0, 0 axis here. So for our purposes, it's much easier when we're aggregating files to put in a lot of files all at once if everybody works from the same origin point. So for us, we'd really like the origin of your model to be at the top of your model at the 0, 0, 0 point. So you can see that right here. It's actually at the top. The second thing is that you're going to want to work with a stock here that I've made. So you've extruded this to be 24 by 24 by 2 inches in the negative Z direction, and then your actual surface will be 16 by 16 in the middle. So first let me just show you one thing, which is the main thing about using our router. We have a 3-axis router, is that you cannot have any undercuts in the router, in your model. So one way to do that is to analyze your surface by going in here and saying draft angle analysis. You're going to click on your surface and then enter. And over here you can see the spectrum that we're looking for. So blue would be pretty shallow, and in this case red would be very steep. So we have, we'll turn off just so we can look a little closer. We don't have a lot of reddish orange even in this model. We have a couple of more vertical surfaces in here, but I think it's going to be okay. One way to really check and make sure you have no undercuts is to set it from 0 to 180. And so at this point 180 means everything's okay, and the blue means everything's okay, and the red would mean that you wouldn't be able to cut it. So it looks like we're okay here. If you'd like to save this for any reason at all, a way that you can do that is by asking it to extract the analysis mesh. So basically what just happened when we did that is we made a mesh, and it's a rendered mesh. So we do that, and now we're going to select this mesh, right? So now we've extracted the mesh. You can see the mesh is overlaying, and as long as we keep this little draft angle box on there, we have the mesh. You see we can adjust the mesh, but if you want to keep this separate from your surface for any reason, you can pick it. Looks like I'm picking my surface, but for now let's just clear them from each other. There we go. Oops, looks like I took my surface with me. Okay, so now I'm just going to move the surface just to show you, and then we're going to actually move on to another file. Okay, so here, if I turn this off now I have the meshes here and I have the surfaces here. And if you're not sure what's what, then you can click on here and you'll see this is a mesh and this is your surface. So in this case, if I want to keep it, I turn this off, and then you can see if I go into rendered that my regular surface is just rendered plain, and then the analysis mesh retain the colors. So if you want to keep that just as a reference, so if as you're changing your surfaces, you're keeping track of what you're doing, you're welcome to do that. Okay, so for now, actually what I'm going to do is go into a different file that I was working with. So we're going to save that. All right, so here's the surface that I went and milled for this class. So just to go back to the layering system, so you have your template that you're going to set up to get started. It looks like I erased it, but I did. Before I did that, I made my stock, and then I made a surface. Okay, so most of you are going to be working on Rhinocam in our lab in FAC 444, and just something that you're going to need to know about in there is that because it's a group lab, there's a few things that you need to know to learn Rhinocam, to load it. So this is actually on our course blog, and Rhinocam is a plugin for Rhino, but it's our CAM interface. You can see it looks like this, and normally when it's loaded, you would have this tab up here. And so you can click on it and you get this machining operations menu over here. If you're in the lab and you pull up Rhino, you've probably noticed after the last bit of the semester that it gives you a question about whether you want to load the software. And if it doesn't, then what you want to do, pull up this document and you're going to go to Plugin Manager, which is going to give you this long list. You're going to scroll down, and then if you don't see Rhinocam, you're going to say Ask to Load Disabled Plugins. And then when you close Rhino and reopen it, you're going to get this dialog box, and you want to click Yes to run Rhinocam. Hi, this is part 3 licenses. Toolpaths. So, but we have more than 5 people in the class. So if you're just in this one, I'm just going to do a brief, you could probably just go in, video showing how to apply custom toolpaths using. And what you want to do is open the license dialog. So in this case, and then this is I've set up some custom toolpaths. There's a number of ways to do that. We'll go over some in class. And I've restricted it just to an area of my model, and then I've called that after a few seconds. The menu will change, and it will display these access codes from the server. What I'm going to do is I'm going to go into the machining objects, and I'm going to select begin work, and you should have the Rhinocam say that I want to select menu curves. Right, if you return to a computer you've used recently, the settings might already be retained, and you don't. You see that little pop-up that says select curves from machining regions. I'm going to right-click in my custom Toolpaths layer, and I'm going to get the option to select objects. So select them. It's fine to go play around, hard return, but if you're going to want to save your settings, and then just to check that they've really transferred into this curves region. As soon as so this is a region just like we picked regions before, where we chose it more by an outline of an area. Make sure that you can Here we're actually choosing regions by the so lines that you're going to log in before you. So these are custom defined. And the last thing I want to mention that are limited to the lines sometimes. So just to check that all worked out, just turn your custom toolpaths on and off, and make sure that when they're off, connect to the key. You're seeing this here. So if for some reason you're having difficulties, the first thing I would say is to go down and now if I go back into your internet access and make sure that you're connected. What I can do is I can go into the program to the internet in order and I can select engraving. So I'll go through a few more setup items. So I'm going to select an engraving, and then I'll start generating toolpaths. What I'm going to do is under regions, instead of picking that big outline that you're going to want to do, I'm going to select
predefined. And this is my
check your
curve region.
machine
Those are
setup.
the curves that I chose
mostly
before.
we
So
should have
we'll
these
say okay.
preset for you, but you do want to check that it's
for this
set
one,
to a
I'd say let's go
3-axis
in
machine.
and use a ball mill.
So you just check this, but it's probably fine. And the second thing is that
And
you're
while it would be
posting
nice to raise the
to the
clearance
Techno
plane,
ISO.
we're pretty tight
That's
on our machine right now.
That's
So
our
let's just
setup
leave
for
it
our
there.
machine.
And
You can go in here. It should say it
gonna be
already,
okay
the
on
current
everything else. So let's
post-processor, but if for
generate
some
that.
reason it doesn't, you just want to check this and make sure
I'm going
that
to
you're
take a
okay.
look at those
And then the
toolpaths. So
posted
what you
file
can see
extension for our
is
machine
it's literally
is
just
an NC
going
file, so
along
that's what you're
each
going
and
to be
every
working
line
on.
and then lifting up
Both
and
of
coming
those
back
should be
down.
fine. So the next
Going
thing that
along
you're
a
going to
line,
want to
lifting
do
up
is set your
and
stock.
coming back down.
So you're going to create generally
So let's
for at
move
least this
that
first exercise
after
and
our
for much of our
parallel
work
finish
this
operation.
semester, you're going to check a box
go
stock,
into
which is just a
simulate.
regular box.
Turn on our
And you can usually,
stock.
in something rectangular, we're just going to copy the model bounding box, and then we're going
I've
to
already
say
run
okay.
the simulation
So,
for the horizontal roughing and for the
In the
horizontal
case
finishing.
of
So let's
checking,
go
what
in
you can
on the
do is
engraving
we
now
have
and run that.
some simulation options.
So you
In
can see
here,
the tool
and you can go
lifting
in,
up,
click on
running along the
simulation
paths.
preferences, and there's a few choices that you
And
might want to
because
make
these
right
lines
off the
are
bat.
spread
So
a lot
a
more
voxel
apart than our
model is,
quarter-inch flat parallel finish
going
that's
to run a
underneath
little
it,
bit faster.
you're going to get that
It's going
kind
to be
of
less complicated. A
really
polygonal model
scalloped,
is going to give you a finer
very
resolution.
textured
So,
surface overlaid on
I
top
had this set for
of
polygonal the other day,
smoother parallel
but
finish.
if
So
you're
by playing with the
finding that you're
consistency
slowing down, you
of
can easily just
the
change
lower
it to the
finish
voxel
and then the top finish, the
The
engraving
other thing
finish,
that you want to pay
can really
attention
get some
to
nice
is the
effects.
transparency.
One thing you might want to
I
do
like to
is
keep
on
it
your
at
parallel
a
finish,
little bit
just leave
transparent
a
on
little
this
bit of
end
the stock
of the
there,
spectrum,
so that you
so
have
that it's
some
not bothering
surface
me when
to
I'm looking
really
at it, but I
dig
can
into
still see where
with
it
this
is.
engraving.
And then we want to keep your tool display to solid display tool. So
That's just
going
going to keep going. There's not a
And then
whole
we're
lot
just
more
going
to
to
say
say
about
okay.
it.
So
I would encourage you
when
to
there's
try
basically
this,
two
even
tabs:
if it's
the
just
program
drawing your
tab
own
for setting
lines,
up your machining operations
on top of your
and
model
the
and
simulate
projecting
tab,
them down,
which
think
is
it would
when
be a
you're
lot of
simulating
fun
the operations. And
to
down
play
here,
around
what's
with
really
some of the
important about
different
this
effects that you can
is
get.
just understanding, in terms of if something's disappearing on you, that there are these different tabs at the bottom depending whether you're in program or in simulate. So in
And that's all
simulate,
for
you
this
can
video.
toggle on and off the actual model. You can toggle on and off the stock to see where that's sitting. You can toggle material texture. Here it's just preset to some sort of wood. The tool path, which we don't have any yet, and then we'll get into that a little bit later. So my main point is that they do look different in the different tabs. So if you're in one or the other and you're confused about why things are working a certain way, just look down at the little buttons down here. So here we can toggle the stock visibility, right? So if we turn off the stock that I have in my model, we can see how this is sitting relative to the foam stock that we're going to be using. There's that material texture. We're going to keep that off. The toolpaths that we're going to generate. These are the main things that we're going to do. Okay, that's going to conclude our setup video, and then the next thing we're going to do is go through tool path generation. Thanks.